Hi, welcome to the Shiko Mathematics Statistical Problem Solving section. So in this video, we continue working on the hypothesis testing. So today we're going to take a look at a different PDF, and we want to find the most powerful test rejection region and the power value for this most powerful test. Okay, so let's go ahead and start. Let me go to the whiteboard and let's start to solving this problems here. All right, so here, okay, so the first things here, we know that this is the PDF we're going to work on today is y to the theta and equal to the 1 plus theta and y plus theta to the negative 2 powers. And then our non-hypothesis here today is theta equal to 0. And the alternative hypothesis here is theta equal to 1. So first, let me write out the PDF here. So when the theta equal to 0, so the PDF for here will just be y to the negative 2 power, right? And so the same things here, this is the PDF y for the theta equal to 1. And then the PDF for this one here will be 2. And then this will be the y plus 1 to the negative 2 powers. Okay, so now after we have this, then we can very easily to find our likelihood functions. So I have likelihood functions. Here we use y. So the likelihood functions here with theta 0 over the likelihood function of the y's here over theta 1 here. All right, so the theta 0, we know is y to the negative 2. So the likelihood function under the non-hypothesis with the sample size y1 to yn will just be y1 times y2 times yn to the negative 2 power. Okay, so the bottom here, this is the likelihood function for the theta equal to the under the HA. So this will be the 2 to the nth power because I have a sample size n. Then this will be what? This will be the y1 plus 1 to the negative 2 times y2 plus 1 to the negative 2 all the way to the yn plus 1 to the negative 2, right? Okay, and then we know this one will be less than or equal to some k value. Okay, so now in here, I can change this negative power. I would do a little bit. So here I can do this will be y1 plus 1 to the positive second power. This is y2 plus 1 to the positive. It's all the way to the yn plus 1 to the positives, right? And then this one I can flip to the bottom. So it will be just to be y1 times y2 and times yn. Then this 2n I can just multiply out. So I can say it's less than or equal to some k star here. All right. Okay, so now I'm going to combine a little bit. So here, this is what I'm going to do. So I'm going to, okay, so here I forgot the second powers here, right? So in here, I'm going to combine the similar term, this one and this one and this ones, right? Okay, so for each one here, so like for the first one, it will be, so this will just be the y1, and this is y1 plus 1 to the square, then times, and then this is just y2 plus 1 to the y2 squares, right? Then till the last ones here, this will just be the yn, this is yn plus 1 to the square less than some constants. This is my rejection region. So in here, then you can simplify this. This will just be 1 plus 1 over y1 to the second, 1 plus y over y2 to the second, all the way to 1 plus 1 over yn to the second less than equal to k star. Okay, so basically this will be my rejection regions, right? So it will be just your times, so it's I from 1 to n. So it's 1 plus 1 over yi, okay, to the square less than some k stars here. So this is the part A. This is my rejection regions here. Okay, so the part B, it says, okay, so if I want to, so part B, so let's say very specifically, if the sample size n equal to 1 and the alpha equal to the 0.05, here, I want to find a numerical value, the point, divide the rejection and non-rejection regions here. Okay, so so let's take a look for the n equal to 1. So this will just simplify to the 1 plus 1 over y once, right? 1 over 1 plus y1 square less than equal to some values here. So then I can simplify that. This will just be 1 plus y1 and less than just the square both sides and some constants k star. Okay, so now I can just say the 1 over y1 is less than equal to the k double star minus 1s, right? So now I will say this one I flip, so that means 1 over y1 is less than here, so I can just say the y1 is greater than some c star. Or you can, this one's here, you can just say that it's a flip to the what is 1 over k star star minus 1. Then you can code the whole things here is just what? Just c stars here. Okay, so now I know my alphas here, right? So my alpha is 0.05. So this is the rejection region. So it will be why it's greater than, right? So it's from the C star to what? To the infinity. Then when it's under the null hypothesis, it's y to the negative 2, right? So this is y to the negative 2 power dy. So then this become a very simple, so this become a very simple integration. So then you can find here. So this will be 1 over C star is equal to what? Equal to my alpha values, right? So this is my alpha value. This is 0.05. So now I can find the very quick one. So that means C star is equal to what? Equal to 20. Correct? So now my rejection region, because the sample size is 1, so I can say the rejection region will just be y is greater than equal to what? Equal to 20. Or if you want, you can say, or you can write this one is 1 plus what? You can say 1 plus y1. Well, here's 1. So you can just say 1 plus 1 over y, right? The square, okay, less than equal to what? 1.1025. Right, so either way you can write here. Okay, so now the last part, let's say, what is the power? All right, so we know the power is when the alternative hypothesis is true and you are in the rejection region. So the rejection region is here, we just find in the part B's, right? So it's y greater than 20, right? So that is why I put a 20 here. And then this is infinity because it's a non-alternative hypothesis true. So what I need to do, I need to use the alternative hypothesis here. So you integrate 2 and this one is what is 1 plus y to the negative 2 powers dy. Then this one become a pretty simple integration also. So this will be the negative 2 And then this is 1 over 1 plus y from the infinity to 20 here. So then if you substitute the value, so the values here, this one finally will be 0.095238. So this will be my powers here. So this ones here, the basically is like, you find the general term of the rejection region. So right now the n is equal to 1. So you just find the 1. What is the rejection regions here? So you find that y1 is greater than, right? Then you just do a simple integration. You can solve it. Okay, that's it. And so the hope this example help you to get a better understanding about how to find the critical regions power for the most powerful test. Okay, that's it. And looking forward to talk to you on our next problem we're going to solve. Okay, bye. Have a good day. Okay.